Life in the wild is a delicate dance, predator and prey, locked in an age-old struggle. Lions stalk gazelle across the savanna, wolves chase elk through moonlit forests, eagles soar high above, searching for unsuspecting rabbits. Predators with their sharp claws, powerful jaws, and cunning strategies play a vital role. They keep ecosystems in balance. But what about the prey? Are they merely helpless victims in this relentless game of cat and mouse? The answer, as we shall see, is a resounding no. While predators may have the upper hand in terms of raw power, prey animals have evolved their own remarkable ways to fight back. From camouflage and mimicry to speed and agility, prey animals have become masters of survival. These are the stories that truly capture the imagination, the tales of the underdog, the unexpected battles where prey turns the tables on their predators. Deep in the African savanna, a drama unfolds. A honey badger notorious for its strength and ferocity approaches a beehive. Its thick skin and sharp claws are formidable weapons. The honey badger is after a sweet treat, the honey stored within the hive. It pays little heed to the buzzing of the bees. The badger begins to tear at the hive, its thick hide protecting it from the initial onslaught of stings. The air fills with the scent of honey and the angry buzzing of the hive's defenders. But the bees are not easily defeated. They have a secret weapon, a defensive strategy honed over millennia. As the honey badger continues its assault, the bees change tactics. They swarm the intruder not to sting, but to sacrifice themselves. They fly into the badger's eyes and nostrils, releasing a pheromone as they die. This pheromone is a call to arms, a signal that sends the entire hive into a frenzy. The honey badger, disoriented and in pain, is forced to retreat. The bees, having successfully defended their home, return to their duties. In the heart of the Amazon rainforest, a different kind of drama unfolds. A venomous snake, perhaps a brightly colored coral snake, slithers through the undergrowth, its forked tongue tasting the air for prey. A small, brightly colored frog sits perched on a leaf, seemingly unaware of the danger lurking nearby. The frog, a poison dart frog, is a vibrant jewel of the rainforest. Its skin, a kaleidoscope of colors, is a warning to predators. The snake, however, is undeterred. It has hunted poison dart frogs before. The snake slithers closer, its movements almost imperceptible, its eyes fixed on the unsuspecting frog. The frog, however, is far from helpless. Just as the snake is about to strike, the frog leaps, but it doesn't leap away from the danger, it leaps directly towards the snake's head. The snake, startled by the unexpected attack, recoils. The snake, feeling the burn of the toxin, thrashes its head trying to dislodge the frog. The mimic octopus, a master of disguise, puts on an underwater show. It can change its appearance in the blink of an eye, morphing its shape and color to match its surroundings. This remarkable creature doesn't just blend in, it impersonates other marine animals, using deception to avoid becoming prey. Imagine a sandy seabed, where a flounder lies buried, its flat body almost invisible. A mimic octopus approaches, its skin rippling with changing patterns. It senses the flounder hidden beneath the sand, a potential meal. But the octopus knows that approaching directly would be foolish. Instead, the octopus transforms itself. It flattens its body, tucking in its tentacles and drawing its eyes together. It changes color, mimicking the mottled brown and white of the sandy bottom. The mimic octopus, its disguise complete, approaches slowly. The flounder, mistaking the tentacle for a meal, darts out from its hiding place, only to find itself caught in the octopus's grip. The African honeybee's defense against the honey badger is a marvel of chemical warfare. Pheromones are chemical signals that animals use to communicate with each other. They are particularly important for social insects like bees, ants, and termites. In the case of the African honeybee, the pheromone released when a bee stings is a rallying cry. It signals to other bees that the hive is under attack and triggers an immediate and aggressive response. The honey badger, for all its toughness, is highly sensitive to this pheromone. The bees, by swarming around the badger's head and stinging around its eyes and nostrils, exploit this sensitivity. The intense pain from the stings, combined with the disorientation caused by the pheromone overload, is enough to deter even the most determined honey badger. This defensive strategy is a testament to the power of collective action. The poison dart frog's defense mechanism is a striking example of aposematism. Aposematism is the advertising of noxiousness, where animals use bright colors, patterns, or sounds to warn potential predators of their toxicity. The poison dart frog's vibrant colors are a clear message. Don't eat me, I'm poisonous. The toxins secreted by poison dart frogs are alkaloids, a class of organic compounds that are often bitter-tasting and poisonous to animals. These toxins vary in potency depending on the species of frog and its diet. Some species like the golden poison frog, Philobates terribilis, are so toxic that a single frog contains enough poison to kill several adult humans. The evolutionary advantage of aposematism is twofold. It deters predators from attacking and teaches them to avoid brightly colored prey in the future. The poison dart frog's defense mechanism is a reminder that nature's beauty can be deceiving. The mimic octopus's ability to impersonate other marine animals is a remarkable example of mimicry. Mimicry is a fascinating adaptation where one species evolves to resemble another species, typically to gain a survival advantage. The mimic octopus engages in Batesian mimicry, where a harmless species evolves to resemble a harmful or dangerous species. The mimic octopus takes this a step further by being able to mimic multiple model species, adapting its disguise depending on the threat or prey it encounters. This ability is due to specialized pigment sacs called chromatophores in its skin. These chromatophores allow the octopus to change color and even texture in a matter of milliseconds. Combined with its flexible body and precise muscle control, the mimic octopus can transform itself into a convincing replica of a wide range of marine creatures. This remarkable adaptation highlights the power of deception in the animal kingdom. The element of surprise plays a crucial role in the success of many prey defenses. When prey animals behave in unexpected ways, it disrupts the predator's carefully honed hunting strategies. Predators, often relying on instinct and experience, can be caught off guard by unusual behaviors, giving the prey a valuable opportunity to escape. In the case of the poison dart frog, its decision to leap toward the snake's head is counterintuitive. This unexpected behavior startles the snake, disrupting its attack and giving the frog the chance to deliver its toxic payload. Similarly, the mimic octopus's ability to transform itself into a harmless-looking creature, only to strike with lightning speed when its prey is within reach, relies on the element of surprise. This reliance on surprise highlights the importance of adaptability and innovation in the evolutionary arms race between predator and prey. The remarkable defenses we've explored are not merely fascinating quirks of nature. They represent a powerful evolutionary advantage, honed over countless generations. These adaptations, whether a bee's pheromone alarm or an octopus's deceptive mimicry, are testaments to the power of natural selection. Consider the honeybee. Its suicidal sting, while seemingly counterintuitive, is a powerful act of self-sacrifice that protects the hive, ensuring the survival of the colony and the propagation of its genes. The poison dart frog's vibrant colors serve as a powerful deterrent to predators. Each brightly colored frog that escapes predation reinforces the effectiveness of this visual warning, further embedding this trait in the species' genetic code. The mimic octopus, with its astonishing ability to morph into different creatures, embodies the concept of adaptive radiation. This evolutionary process describes the rapid diversification of a single ancestral species into a multitude of forms, each adapted to a specific ecological niche. The mimic octopus, through its mastery of disguise, has carved out a unique niche for itself in the competitive marine environment. These adaptations, passed down from parent to offspring, represent a legacy of survival. Each generation inherits the successful strategies of its predecessors, fine-tuned over millennia. The success of these adaptations is evident in the continued existence of these species. The intricate dance between predator and prey is a delicate balancing act, a continuous struggle that shapes the dynamics of ecosystems worldwide. The adaptations we've explored are not static solutions. They are part of an ongoing arms race, where each species constantly evolves in response to the other. As predators develop keener senses, faster reflexes, and more sophisticated hunting techniques, prey animals must counter with even more effective defenses. This constant pressure to outmaneuver the other drives the evolution of both predator and prey, leading to ever more sophisticated adaptations and counter-adaptations. Predators, by keeping prey populations in check, prevent overgrazing and resource depletion. This intricate interplay ensures the long-term health and resilience of ecosystems. The study of prey defenses provides a fascinating glimpse into the ongoing dialogue between predator and prey. It reveals a world of intricate interactions, where each species constantly adapts and innovates to survive. These adaptations, far from being isolated occurrences, are woven into the very fabric of the natural world, shaping the relationships between species and influencing the delicate balance of ecosystems. By unraveling the secrets of these defenses, we gain a deeper appreciation for the complexity and ingenuity of the natural world. We begin to understand that even the smallest and seemingly most vulnerable creatures possess remarkable abilities to survive and thrive in a world filled with challenges. The stories of prey outsmarting predators serve as a powerful reminder of the importance of adaptation, innovation, and the interconnectedness of all living things. They inspire us to look beyond the surface of the natural world and appreciate the intricate web of life that surrounds us. These tales of survival, passed down through generations, remind us that the struggle for existence is a powerful force, shaping the diversity and wonder of life on Earth. The tales of prey outsmarting predators offer profound lessons in resilience, adaptability, and the sheer ingenuity of the natural world. They remind us that even in the face of seemingly insurmountable odds, life finds a way. These stories challenge our assumptions about the weak and the strong, revealing the remarkable strategies that enable even the most vulnerable creatures to thrive in a world of constant challenges. The honeybee, sacrificing itself to protect its hive, embodies the power of collective action and the unwavering commitment to the survival of the community. Its story reminds us that cooperation and selflessness can be formidable weapons in the struggle for existence. The poison dart frog, adorned in its vibrant warning colors, teaches us that vulnerability can be a strength, a deterrent that protects rather than endangers. The mimic octopus, a master of disguise and deception, highlights the importance of adaptability and innovation in a constantly changing world. Its ability to transform itself to match its surroundings reminds us that survival often depends on our capacity to adapt to new challenges and exploit opportunities as they arise. The struggle between predator and prey is a testament to the interconnectedness of all living things. It highlights the delicate balance that sustains ecosystems. Predators regulate prey populations, ensuring ecosystem health. Prey drive predator evolution, creating a cycle of adaptation. This dance of life and death maintains biodiversity. The intricate relationships between predator and prey are but one thread in the vast tapestry of life on Earth. Every species, from the smallest insect to the largest mammal, plays a role in maintaining the delicate balance of our planet's ecosystems. These intricate connections, often invisible to the casual observer, bind us together in a web of interdependence that sustains life in all its forms. The air we breathe, the water we drink, the food we eat, all are products of this intricate web of life. The bees that pollinate our crops, the worms that enrich our soil, the forests that regulate our climate, all are essential components of a healthy planet. The stories of prey outsmarting predators remind us that even seemingly insignificant creatures play vital roles in this grand ecological drama. By understanding these connections, we begin to appreciate the profound consequences of our actions on the natural world. We realize that the destruction of habitats, the pollution of our air and water, and the unsustainable exploitation of natural resources threaten not only the survival of countless species, but also our own well-being. As we marvel at the remarkable adaptations of prey animals, we are reminded of our own place in the intricate web of life. We too are part of nature, subject to the same evolutionary pressures. These stories of survival offer valuable lessons for our journey. They teach us resilience, adaptability, and respect for interconnectedness.